Welcome. Let's learn about operations with rational expressions. Rational means fractions. Expressions is no equal sign. And you definitely have to be able to factor to be able to do these problems. We're going to look at multiplying, dividing, adding and subtracting, simplifying along the way, even with -1. Let's get ready. You're going to need your notes and pencils. We'll do some problems along the way so you can pause and try them. And just a reminder on operations with fractions because they're going to be the same once we turn them into polynomials. When you're multiplying, you multiply straight across the numerators together, and then you can simplify. When you divide, you flip the second fraction, so you multiply by the reciprocal, and then you multiply across. When you add, you have to get a common denominator. Think about what you're doing. I have to do 3 times 4 and 2 times 4, so I'm multiplying by the missing factor. And with subtraction, we also get a common denominator. And then this is 12, and then times 3, so we get 5/12. So common denominator is going to be an important piece with our polynomials. When we simplify, you need to remember your rules of exponents. It's going to be a lot of factoring, and then canceling, remember when you have the same thing on top and bottom, so it really equals 1. You may have to factor out a -1, and then this is going to be new. We're going to limit x because we can't have a 0 in our denominator, so we don't want x to make it happen. In the first example, we have our rules of exponents, so I'm going to deal with just my numbers and divide them, and then remember the rules of exponents. When you're dividing, you're going to subtract your exponents. I need to limit x, so I don't want my denominator to be 0, so I have to say x cannot be 0. In the middle one, we're going to factor. So the top one factors to x minus 3 and x plus 1. And the bottom one factors to x plus 4 and x plus 1. X plus 1s will simplify to 1. And then my answer is x minus 3 over x plus 4. I need to think about what my limits are, and it comes from my denominator, both factored pieces. Even though I cross this out, I have to be able to make the original work. So if we plugged in -1, that would make that 0. So x here can't be -4 or -1. When we factor here, I do give you the hint of factoring out a -1, but let's say I don't know that, so I'm going to factor out x, and I leave behind a 2 minus x, and the denominator that factors to x minus 2 and x plus 1. These look almost the same, but we have to be careful. They don't simplify to 1, but if I took out a -1 and then changed the signs, now they will simplify, and I get my answer to be -x over x plus 1, where x cannot be 2 or -1. When we multiply, some more rules of exponents, factor, and cancel, and we have to make sure we're still limiting that domain. Our first example is just monomial, so I can simplify. 15 and 3 divides to 5, and then 2, 8 is 1/4, so I have a 4 down there. I'm going to multiply across, so I get 5. I add my exponents. Don't lose that 4, so I have 4x to the 5th, y squared, and then I work down the columns. So 5/4 stays like that, and then I have x, y to the 3. I should say that x and y cannot be 0. The second one is now polynomials, binomials in this case. So we can factor and factor. So let's start with that. Can take out a GCF. And the second denominator is a difference of 2 squares, so we can factor that. Wherever you have the same exact factor on the top and the bottom, that can simplify to 1. So it doesn't have to be right above it. So x plus 4, x plus 4, x plus 2, x plus 2. Be careful. We canceled that all out, but really it is still a 1, so don't make your denominator come up into your numerator. We need to consider all the pieces with our limit, so x can't be -4 or 2 or -2. Multiplying, go ahead and try this. I'm going to factor out the 10, leaves behind x minus 4. I'm going to factor x minus 4 and x minus 2. Take out a greatest common factor of 5. And we can simplify that. Don't lose that 5. That goes with the 10, so that's 2. So I get 2 that crossed, over x minus 2, where x cannot be 4, 2, or negative 3. When we divide, remember we are multiplying by the reciprocal. It's always the second fraction. So we want to flip, factor, cancel. We're still setting our limits. So I'm going to rewrite this, doing the reciprocal of the second fraction. Simplify my numbers. Don't lose that 4. Across the top, I'm going to multiply. And then I can go down. Include x and y cannot be 0. Now we're going to look at dividing when we have their polynomials. So we need to factor, and it is division, so I'm going to do the reciprocal and factor at the same time. For the first one, I can take out an x cubed. It leaves behind x squared minus 4. That's a difference of 2 squares, so I'm going to continue factoring. Make sure you factor fully. In the denominator, it factors to x minus 2 and x plus 1. When I flip, I'm looking at this one, which is a difference of 2 squares, so we have x minus 1 and x plus 1. And then this, I'm going to take out an x cubed, see what that leaves behind so that I can factor that. That's going to factor to the same thing, x minus 2, x plus 1. X minus 2's cancel, x plus 1's cancel. And I did have this original x cubed that I forgot, which would go down here, and that's going to cancel. So I end up with x plus 2, x minus 1 all over x minus 2. X cannot be 2, negative 1, 0 from this x cubed. That's still 2, negative 1. I still have to go up to my numerator because it was originally my denominator, so it can't be a positive 1 either. So when you restrict your limit, that comes from all 3 places. Go ahead and try this. I'm going to factor and flip. So when I factor this, difference of 2 squares, I'm going to flip, so I'm going to take out a 4 first. And then that becomes my numerator, so I'm going to factor minus, minus. And the last one is a difference of 2 squares. Simplify. Plus, plus. I have a 4, an x minus 4, and an x minus 3 left. My limit comes from every piece of my factored denominator. 3, negative 3, 1/2, negative 1/2, and what is now my numerator, but I think that's all the same thing. So those are all 4. Adding and subtracting. So when you add or subtract, you need to have the common denominator. These are ready to go, so you would just be combining like terms. When you subtract, put this in parentheses and make sure you're distributing there. However, we're going to more see when we don't have a common denominator, so we need to get one. You need to factor so you can see what pieces it's made up of. So the first fraction has an x plus 2 and an x plus 1. The second fraction already has an x plus 1, so I need an x plus 2. So I can multiply top and bottom by that and distribute. So I have x minus 1 plus x squared plus 2x, which is going to simplify to x squared plus 3x minus 1, which is not factorable. Keep your denominator in factored form. It's just easier to see what your limits can't be. And that would be my simplified answer. Here we're going to factor the second denominator. It's a difference, or a perfect square trinomial. So, oops, that's a 3. So this one needs an x plus 3 and an x plus 3. I can distribute. So I get x squared plus 3x plus 2x plus 6. I'm going to combine like terms and then factor all over x plus 3 squared. That will simplify to 1. This will be my answer, and x cannot be negative 3. Go ahead and try this one. I'm going to factor the first, take out a 2, leaves behind x squared minus 8. X minus 2, x plus 2. And then we have x. I'm going to multiply this one by the x minus 2. So that becomes x squared plus 2x minus 8 all over x plus 2. It is subtraction, so I need to make sure I'm distributing my negative. I'm going to go back to standard form. That's why that looked funny to me. I want to keep that in standard form so I can combine like terms. So 2x squared minus x squared is x squared minus 2x. Negative 16 minus a negative 8 is minus 8 all over x minus 2x plus 2. I can factor that numerator, minus 4 plus 2. That's my simplified answer. X can't be 2 or negative 2. Simplifying complex fractions. This is my fraction bar, so I want to combine this to one fraction, and then we'll multiply by the reciprocal. So I need common denominator, so I'm going to multiply both of those by 4, multiply this by x, and I end up with 8 plus x squared over 4x. I'm going to multiply by the reciprocal of this, which is x over x plus 1. My x's can simplify. I can't simplify anything else, so it becomes 8 plus x squared over 4x plus 1. Go ahead and try it. Want to get a common denominator here, so this one needs to get multiplied by 2. So I end up having 3 over 2x times the reciprocal of x minus 2 over x plus 4. Nothing can simplify, so that is the answer. So just to recap, when you add or subtract, you have to remember to get a common denominator. Multiply, you are factoring and simplifying. Dividing, you factor, multiply by the reciprocal, and simplify. And complex fractions, you're multiplying by the reciprocal. For all of them, we need to make sure we're remembering to limit our denominator. Good job.